Hello everyone, good morning. This is particularly about the wall line in a modular home manufacturer. But to start with, we're just going to have a discussion of the motivation for another project that we did, which had to do with the floor line in the same company. So we started here, and these are 4 animations that should start soon, slower than it was this morning, so we basically go in, look at what they do, and look at the waste in different ones. But it was working this morning when we tested it. So in the top 2, this is kind of the first 2 processes in them making the rim boards for the floor. And then we kind of go in, ask them, where are your wastes? So in the other slide, we had the 7 different wastes in lean theory. And we talk to them about them, help them identify them, and then we kind of talk with them and they come up with another idea of how they could help eliminate the waste. So in the bottom here you can see that they've eliminated lots of the moving for the different pieces. They've eliminated the need to gather people to lift up the rim boards. So they've eliminated waste and increased their production with the help of some very limited equipment. The next one is the next 2 steps. So again, we have lots of walking. They're walking out individual floor joists. They're stepping over things. There's safety risks. And again, how can we eliminate that waste in a similar way? So next, we moved on to the floor line. To the wall line. They had a faster floor line. How could they improve their wall line? So they had a goal, a target production of 4 houses walls per day. And then we decided to use simulation to test the ideas that we had for improving the production to see what they thought was the best. So their wall line, a quick overview. They have the top and bottom plates or the rim boards. Then they separately build the door and the window opening components. They have another station for the exterior wall panel construction, another for the interior wall framing, another for special shape walls, and then another to do the wall poly and the drywall. So an important thing when we did this, we did time studies, talked to the experts there to come up with the durations for our simulation model, but it was important not to just do random times for everything, because when we talk about standardization, all of the home builders right away say, we can't standardize. This is everything's different. It's built to order. It's what the customer wants. So we kind of talk more about standardization for specific things. Even if your wall time can't be standardized, you can standardize the time to build a window. You can standardize the time to put in one stud. So we looked at the different characteristic variables of the home and then the different time variables that can be standardized and that they could come up with a specific time for. From there, we go into defining the variables for the simulation model, and the bottom table here is kind of like a example. So we did lots of interviewing the experts for time constraints on this project and used some triangular distributions to have variation still, but with the standardized components. We also had resource constraints in the simulation model, so different number of people for each station. This is just a quick overview of the simulation model. So there's some lines that run in parallel to each other, others that are prerequisites for the next station, and then the different coding that needs to go into each one to pick the specific time for the studs, how many studs are in each wall, what's going to happen from there. So we first built the current state simulation model, and then we need to validate it to make sure that anything that we're going to propose from there is valid. So we got the the production of 1.9 houses walls completed per day, which is what they were seeing. And from there we proposed 2 different improvements. So the traditional classic, just throw more people at it, and the other one of changing your equipment, eliminating your waste, having a more permanent, reasonable solution. So when we talked about the labor change, you can see in the current state there that is the opening station construction time and the exterior wall framing construction time that were definitely the bottlenecks of the process. With adding 2 more people, we eliminated some of the time, but especially the exterior wall framing process was still a major bottleneck in the scenario. And it only increased the production to the walls for 2.5 houses per day. So it wasn't hitting their target. We still had a major bottleneck, unbalanced production line. So we knew right away that there was probably a better solution. From there, this is a different project that people in our group are working on as an example, but this is a steel framing wall. This project is about wood, but how can we use semi-automated equipment or simple machinery to help eliminate the waste, have the right tools so that people can increase their production time. So this is a light gauge steel framing machine that can help to standardize the time to put in each connection. So with a similar idea for wood, we eliminated some of the wasted time, like the walking out of the joists in the of the studs in the simulation model, and then we looked at the future state time for this. So again, the two major stations in the green, you can see that it decreased the opening station time and also decreased the exterior wall framing construction time. So now you can see we have a more balanced production line. We still have some stations that could probably have more value added in them because they have such short times. But in the orange there, you can see how those compare now to the other opening stations. So we're moving towards a more balanced, reasonable production line. So this is the animation for the wood, one idea for the equipment that can be used to standardize the wood framing. So here we have pre-drill, we have the tools fixed, we have the people not needing to walk things out. And then another thing that we notice is inherently there's a lot of safety that comes along with this too. We don't have people stepping over things, we don't have people bending down, we don't have wires all over for people to trip on. So there's a bunch of other kind of added bonuses that came along with this. So the most important part, what did the company do about it? So after looking at what we did here, instead of the company just throwing more people at it, which happens a lot, after they saw that we can only probably increase the production by about 34% by adding 2 more people, or by 79% by using the automated framing machine because that exterior wall framing station was so slow and was causing everything else to be slower, that's what they wanted to do. After a couple iterations after this, the company decided to implement not the material delivery bridge and everything, but instead a CNC saw for having the pieces prepared for wall framing, also pre-drill for the wires. So everything's done ready to go, no waiting, everything's measured. And they also invested in the lasers for the measuring. So you can see in the picture there with the crosses, they don't need to measure any of the wall things. So kind of the same thing that was happening on the jig with the measurement. Instead, they decided to go with a jig with the lasers. So instead of people measuring and marking every time they go to build a wall, they just select their file on the computer and they know exactly where they need to put the piece. So again, that's eliminating one of the very variable pieces that we have and making it standard, because one person could take 5 minutes to measure out a wall, the next one could take 15. And then one thing that we found, I'm just going to go back to the last one for a second, that I forgot to mention, was the variation. It's probably too far gone now, but the variation we also found decreased from about half of an hour for each one to about 0.2 of an hour for each of the things. So in conclusion, the use of the simulation can help to verify the proposed improvements and also to help convince companies how can lean ideas be implemented better and take more time to think about what you're going to do instead of just throwing people at it and fixing the problem for the short term. Thank you.